Okay, so we're going to continue from yesterday. And before I start this problem, I took the time to write down the steps. And you might want to copy these. Of course, I'm recording right now, so this will be out online tonight. So if you want to get it off the video, you're welcome to do that, but be quick. All right. You may take a picture, but put your phone up quickly. So step 1 is to find your A, B, and C value. So identify A, B, and C. Step 2 is to find your axis of symmetry, your x coordinate. And how do we find that x? It's negative b over 2a. Then you lightly sketch your axis of symmetry. Lightly sketch, because you don't want to get it confused for your x and y axis. Step 3 is to plug your x coordinate into the original equation and solve for y. Then you plot your vertex. And I have there that y is equal to f of negative b over 2a, because that's basically what you're doing. You're taking what you got for x, which was negative b over 2a, and plugging it into the original equation. Step 4 is to plot your y-intercept, which is your c value, and reflect it across your axis of symmetry. Step 5 is to check your a value against, is it upwards or downwards opening parabola? Does it fit? So are you headed in the right direction? You've got to get an idea of, okay, it should look like this. Is this what's happening? And if it checks out and it looks like that's what it's supposed to do, then draw your smooth curve. If there's something that didn't check out, of course, go back to the appropriate step and recalculate. So this is what we're going to do. So let's apply this process to problem 2. Problem 2 says graphing a function from the standard form of a quadratic function. So what is the graph of y equals x squared plus 2x plus 3? So step 1 was to do what? Find A, B, and C. So what is my A here? We know let's write the original equation. What is it? F of x equals ax squared plus bx plus c. So my a value becomes, I heard someone say it, 1. So my a is equal to 1. What's my b equal to? 2. And what's my c equal to? 3. So a is 1, b is 2, c is 3. So there it is in the step right here. Okay, so our next step is to calculate our x value, get our axis of symmetry. So to get that, we use that formula, negative b over 2a. X equals negative b over 2a. So that will give us our line of symmetry, which is also the first point in our coordinate point for the vertex. So plug in your b. So we've got negative. So write your negative, and then substitute 2 for b, right there, and 1 for a. So you have negative 2 over 2 times 1. Well, 2 times 1 is 2, and negative 2 over 2 is negative 1. So now we've got our line, our axis of symmetry, and the first part of our vertex. So lightly sketch your axis of symmetry across that x-axis at the negative 1 point. Step 3, you take your x coordinate of your vertex and plug it back in to your original equation. Okay? And when you do, you're going to plug in that negative 1 for all the x's in there, and then solve. And when you do, you get 2. So that's your y value. Y value is 2. So now we have our x, which was negative 1, and our y value, which is 2. So now we have our vertex. Let's plot that. So we go back 1 and up 2. Right. So it's right here. Plot your vertex. Look at your a value. Is it positive or negative? Is it a positive 1 or a negative 1? It positive 1. So that means it's an upwards facing parabola. So we would expect from this point right here, it's going to be going upwards. Well, let's plot our y-intercept. Well, how do you get your y-intercept again? You turn x to 0, right? So if we turn x to 0, we get 0 squared, which is 0, plus 2 times 0, which is 0, plus 3. So our y-intercept is 0, 3. So let's go up there and do it. There's 0, 1, 2, 3, right there. There's our y-intercept. Now, that is 1 unit away from our axis of symmetry, so reflect it across that axis of symmetry over here. 1 unit away. Now we have 3 points, and we know it's upwards facing. These 3 points appear to create a parabola that's upward facing, so let's smoothly graph it now. And that's how you graph your parabolas. Okay? Any questions over that? Okay, so what you need to work next is on the back of your whiteboard, on the graphing side, I want you to graph this equation using those steps that you just copied. Okay? So for those of you who took a picture, I don't want you to get your phone back out. Keep that put up and I'll turn it back to the steps. So make sure right now that you've copied this equation. Y equals negative 2x squared plus 2x minus 5. Okay, and I'll go back to the step page. If I can find it again. There. All right. And I'm going to give you 5 minutes. Actually 4. It shouldn't take 5. And if you finish early, double check your work. Look around and see if somebody's struggling. If they are, help them. All right. I'm going to pause the video now. First row, let's see your work. Hold it up, please. Okay. Did you graph it on the back? Okay. Second row. Don't erase yet. And if you graphed it, let me see your graph too. Third row. Fourth row. Fifth row. Sixth row. Seventh row. Okay. You know, yesterday I saw several, more than I could count on one hand, who didn't even know where to start when we did this. Today, it looks like there were just 2 in the class that are still just completely lost. Guys, you need to speak up when you have these few minutes. That's golden time for you to turn around and say, can someone please help me? Can you please help me? And I'm standing back watching the process. Okay, this is your time to help each other, okay? Because I've taught it, now it's time for you to gather together, put your heads together as a group and figure it out. Question?
I know how to graph the vertex and the axis of symmetry, but what do you mean when you're talking about the minimum, maximum, and the range?
Okay, so that was on our homework yesterday. So let's go over this again. Let's go over this together. Then her question was, she knows how to find the x and y value, but she doesn't understand the max and min and the range. Okay, and it has everything to do with the vertex, and I'll hopefully make that clear to you now. So let's look at this problem. We've got y, don't erase. Okay, because what you need to do is check your work against mine. Never erase your whiteboards, guys, because this is the learning process, is to check your work against mine. I didn't give you the correct answer. You have no idea if what you did was good time or wasted time. Well, it's never wasted if you were working through it. But the whole point is you've got to see, did you do it correctly? So never erase your whiteboards, okay? Now, let's go through this together. If you erased, you've got to write this again, step by step. Go through the process with me. So, the first thing we're going to do is to define our A, B, and C. So, our A is -2, our B is 2, and our C is a -5. All right. So for my A value, I see it's a -2, so we know it's going to be a downwards facing parabola. I've already got that picture in my head, right? And I know I've got a y-intercept of -5. Okay, so we know somewhere it's going to be crossing through the y-intercept, either on this side or that side. We don't know where it's going to be at a -5, but it's going to be somewhere there. So we have A equals -2, B equals 2, and C equals -5. That's a negative. Got a slippery spot there. All right, my next step is to get my x value. My y-intercept, or excuse me, my axis of symmetry is my x value. So x equal -b over 2a. Well, that's going to be equal to -b, and b is 2. I'm going to always put my variables in parentheses, so it will help me keep my sign straight. Over 2 times a, which is a -2. Okay, Brissa, you need to be writing with us. And is there anybody else? Come on. Work the process. So now we have -2 over -4. That cancels out to 1/2. Okay, so your x value, we've got our x value is equal to 1/2. So we've got part of our answer. Now we're going to plug that back into this original equation and get our y. So it's going to be y equals, that's what we're trying to solve for, right? We need to find our y, and there it is right in front of us. Y equals what? -2x squared plus 2x minus 5. And we just said, well, for our axis of symmetry, our x value is 1/2. So to get our y, we're going to plug in 1/2 for x. So it becomes f, oops. Put that back. F of 1/2 equals -2 times 1/2 squared plus 2 times 1/2 minus 5. Well, 1/2 squared is just 1/2 times 1/2, that's 1/4. And we're still going to multiply that by a -2. And then 1/2 of 2 is just 1 minus 5. Now I'm going to multiply -2 times 1/4. That becomes -2 over 4. And then -5 plus 1 is just -4. This simplifies to 1/2. So I have -1/2 minus 4, which is equal to -4.5, or 4.5. Okay? So depending on how you want to write it, you can write it as, whoops. Let's try this again. You can write it as 1/2 -4 and 1/2, or you can write it as 0.5 -4.5. All right, so there, this is my axis of symmetry, and this is my vertex. So let's plot those. So I'm surprised that you're not going back and forth like this as you work. You should be going back and forth. As you get these things, you should be going back, okay, my axis of symmetry was at 1/2. So here's 1. I'm going to go ahead and draw my axis of symmetry at 1/2. Okay, that you should do after your first, after you get your x value. Now we got our y value, -4.5. So let's go down 1, 2, 3, 4, 5. So my 4.5 is going to be about right here. There's my vertex. And we said our a value is negative, so it's going to be going upside down. I'm going to be needing lots more room. So be careful of that when you start graphing. Like if you were at the bottom of your page, you would probably have to erase it and start over. or go to another page. So now we have that. We've got our vertex, we've got our axis of symmetry. Now I'm going to plot my y-intercept, which is 5. Negative 5, excuse me. So I'm going to come down here. There's my negative 5. And then I'm going to reflect that point. So if this is a half a unit, if that's half a unit from the axis of symmetry, then I'm going to reflect it a half a unit from my axis of symmetry on the other side. Right there. Now I've got enough to say I can graph this parabola. It's going to basically look like this. And that's all there is to it, guys. Okay, now let's talk about the max, min, and the range. Okay, the max and min refers to your vertex. So in an upside down, a frown type parabola, where your a value is negative, is your vertex at the highest point of the parabola or the lowest point? Highest. So we call that a max. In a right side up or an upwards facing, a smile type parabola, our vertex is here. Is it the highest point of the parabola or the lowest point of the parabola? It's at the lowest, so we call that a min. Okay, your max or min value is always going to be what? It's just going to be your y value. Whatever you calculated y to be, that's what it's going to be. But you have to look, is it upwards facing or downwards facing to decide if it's a max or a min. All right, so we knew our y value was negative 4.5. So it was at the highest point of the parabola, so we say this max value was negative 4.5. Good? All right, so are you good with the max and min? All right, now if we're talking about range, we're talking about, hold on, let me clear this off. We're talking about what values can y have for this parabola. Let me change shade colors here. So this parabola is here. What y values can we have? Well, it looks like it started at negative 4.5, right? Because that's our y value. So there's another key. It's always going to be around your y value. So is it going greater than that or less than that? It's going less than. So you're going to say the y value for the range. The range is always your y value. Y is going to be less than or equal to negative 4.5. So where did the parabola start and where does it go? It goes on forever. Are you good with that now? All right. Any other questions on the graphing process, the max, min, or the range? All right. Let's move forward. Okay, so now they're going to ask us to convert to the standard form to a vertex form. So remember in lesson 4-1 we did a vertex formula. Well, now they want us to look at a standard form and convert it to vertex form because we're going to need these skills in the upcoming lessons. So what are they going to do? They're going to give us an equation. What is the vertex form of y equals 2x squared plus 10x plus 7? So I see right now I've got a y-intercept of what? 7. And is it upwards facing or downwards facing? Upwards. What's my a value?
2.
What's my b?
2.
And what's my c?
7.
Very good. So you guys are on your way. So what we have to do is get our x and y value. Remember in our vertex form, what was that equation? It was f of x or y equals a times x minus h squared plus k. So which one was x and y? Which one was h? Was that x or y? That's our x, and that means that k must be our y. So if we can just get our vertex, because that's all h and k was, remember? If we can just get our x and y value like we've been doing, we can just take the x and y and plug it into this formula, find our a value, and be done. Okay, so let's do that. So we need to identify our A, B, and notice that they're not even asking us for C because we really don't need it right now. We're going to plug that into our formula for axis of symmetry, negative B over 2A. So it's going to be negative 10 over 2 times 2. And you get a negative 10/4, or simplified negative 2.5. Okay, so it's the same thing we've been doing. So we've got our x value now. So that's going to become our h, right? So it's going to be negative 2.5. I'm just going to write it underneath there. Now plug that back in and get your y, and we're going to substitute that for our k. So when you plug in negative 2.5 into the original formula and solve, you get negative 5.5. So now there's our negative 5.5 is going to become our k. Now substitute those new values in. That's our vertex. Oh, we have to get our a value also. So what is our a value? We already have it, right? What is our a value here? 2. Remember how we used to have to calculate for a value, and it was like the end thing that we had to do, and it was very tedious to get our a value? We don't have to do that anymore. If you've got it in the standard form, all you have to do is pluck your a value out, and there you go. So now we know our a value is 2. See how easy that is? Now just plug in your values and you're done. Make sure you keep it in the vertex form though. So we're going to plug in a 2 for a, negative 2.5 for h, and negative 5.5 for k. And clean up your signs. Negative times a negative is a positive. And the bottom result is, there's your equation. There's your vertex form. The same equation translated to vertex form. Y equals 2 times the sum of x plus 2.5 squared minus 5.5. And that is it. Any questions over that? Pretty easy, because it's the same thing, not even as much work as we've been doing, and we just plug it back in for our h and k and clean up the signs. So you'll have some of those. And now I want to show you the last thing, a word problem. And this is a really nice word problem. It's fun. It's a little puzzle as well as, you know, a learning activity. It says interpreting a quadratic graph. We know quadratic, what kind of graph does it make? A parabola. Is this one, would the a value be positive or negative? Negative, because it's downwards facing, right? So we know we've got a negative a value already, right? So let's read about it. Bridges. The New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You can model the arch with the function y equals negative 0.000498 x squared plus 0.847x, where x and y are in feet. How high above the river is the arch? They want to know how high from there to there. I guess I need a different color highlighter though. Let's do pink. Here we go. How high from the river is that arch? So that's the first question. And the second question is, how long is the section of bridge above the arch? So there's the arch, there's the arch. They want to know, how long is this right here, the road? Okay, so if we think of this on a coordinate plane, really, it would do this, right? So here would be our, possibly. If we can find the vertex, right, we know the distance from 0. And then whatever that vertex is, that y value is, all we have to do is add that plus this, 516. So if this was, let's just play like this is 2 feet high right here, that's at y equals 2. It's not, but for example's sake, we'll say it's 2. Then you're going to add 516 plus 2, and that would give you the total height. Do you see that? So that's our plan of attack, just to try to get the vertex so we can get our height. And if we have the vertex 2, think of what the x value gives us. The x value is going to give us this 1/2 of it. And then all we have to do is double it to get the whole thing. So if we can get our x and y, that's all we need to solve this. So let's do that. Let's find our vertex. So start with your equation and get your a and your b. There's no c. There wasn't a c value there, so c is 0. So a becomes that. B becomes that. Sorry, it's overlapping onto my x squared. So, there we go. And there's no c, so c is 0. But all we need is a and b, so we're good. So you're going to plug it into our x equal negative b over 2a, and when you calculate that, you get 850, approximately. They're rounding up a little. So 850. Then you plug that 850 into your original equation, solve it, and you get around 360. So there's your vertex, 850, 360. And when we plot that, we know when it's a negative a, so it's downwards facing. So there's your vertex. And your y-intercept would be 0, right? And we could reflect that over here. So now we've got our graph. Okay, so when c is missing, that means that c is equal to 0. That's your y-intercept. It's going to cross at the origin. So we have everything we need now. So we know from the origin halfway to the vertex, the x value is what? 800. So the length of that bridge is 800 times 2, which would be 1600. And the height is going to be the y value, 360, plus that height underneath the bridge. 360 plus 516, and that's going to equal 876 feet. So it's 876 feet above the water, and it's 1,700 feet long. Oh, sorry, that wasn't a perfect 800. It's 850. Sorry, I looked at it as 800, but it's 850. So 850 times 2 is 1,700. See, 1,600's there. It's just a big graph. All right, so it's actually 1,700 because it's 850 times 2, which is 1,700 feet. All right, so that's all there is to that. And as I tell you, word problems, heads up please, heads up. Word problems are a lot easier than what you think because everything's right there and you've got the visual representation. You've got visual cues to help you keep moving along. Okay, so don't balk at the word problems because a lot of this test is word problems. You've got to be doing these and understanding. And if you realize this was actually sort of easier than all the other things we worked today. Are there any questions on this? Yes? A and B? Okay, very good question. The question was, how do you know what A and B and C is? Well, they gave you this equation here in the original problem. Here we go. Right here. They tell you you can model the arch with this function, and they gave us this function right there. So it's y equals negative 0.000498 x squared plus 0.847x. And so there's your A, there's your B, and there wasn't a C, so it's just going to be a 0. So that's your A, your B, and your C. That's how you get the A, B, and C. So it's always going to be right there. Everything you need is going to be in these words, and you just have to pluck out that function to get your A, B, and C. Don't let the decimals mix you up because you've got a calculator. Just plug them into a calculator if you don't want to do that manually. All right? Your assignment tonight, which most of you are already putting up, it's 4-2, and I want you to do the remaining evens. So 4 through 20 evens. I want to see work. If I don't see supporting work and all I have is answers, I'm going to assume you just copied it from an answer key, which there are many I see floating around, or that you just copied from someone else. So you don't expect a grade if you turn in answers only. Okay, I've got to see, I want to see that you pluck out ABC. I want to see that you plugged them into the formula. I want to see your calculations. Even if it's on scrap paper, attach that, but make sure that it's nicely, I can find your work easily. Like this is number 1. Draw, if it's half a page, draw a line underneath it. Okay, so I have to see your work. No work, no credit. Any questions? Okay, this is due tomorrow when you walk in, and we'll move on. Thank you very much. That concludes our lesson today.